Many people have some difficulty in getting started writing equations for reactions of acids, so I thought I'd put out a few slides just to resume what you probably have already done at high school. First of all, in order to do any of these equations, you do need to learn the rules. So I put together the four main rules plus one about ammonia called Rule 5. So the first one is you have to identify whether a chemical is an acid or alkali, because an acid will react to neutralise an alkali to make salt and water. An alkali is usually a hydroxide, so we're talking about sodium hydroxide, potassium hydroxide from group 1, or calcium hydroxide from group 2. The second rule then is where your acid reacts with a base, and the base will neutralise the acid to make salt and water. A base is usually a metal oxide like magnesium oxide or copper oxide, possibly even calcium oxide. These will neutralise the acid but generally are insoluble. Third rule is an acid with a reactive metal, so we're looking at a metal that's above hydrogen in the reactivity series, so when they react together they make salt and hydrogen. Reactive metals are usually things like potassium, sodium and calcium, sort of reactive metals in group 1 and group 2. Fourth rule covers both carbonates and hydrogen carbonates. These chemicals react to neutralise the acids to make salt water and carbon dioxide. Sort of examples of carbonates include things like copper carbonate and calcium carbonate, and you can tell from the name whether they're hydrogen carbonates, so you might get something like sodium hydrogen carbonate. The last reaction I put together is occasionally when we get ammonium salt, so acidic chemicals, reacting with ammonia to make ammonium salt. So I'll put one example in later on for those. The first job you have to do then is be able to name the salts. So having established that you're going to neutralise your acid to make a salt, you need then to put the name together in two parts. So the two parts come from, the first bit comes from the metal from the chemical reacting with the acid. So for example, you might have a salt called sodium chloride, and the metal in sodium chloride is obviously sodium. Just to check on the periodic table, the metals are on the left hand side of the periodic table, just in case you were unfamiliar with some of the metals. The second part of the salt's name comes from the acid that you're neutralising. So common things are like hydrochloric acid making chlorides, sulfuric acid making sulfates, etc. So in this case, if you've got sodium chloride, that's come from neutralising hydrochloric acid. So you need to identify the metal from the chemical reacting with the acid and learn the acid endings. It's obviously simple if you've learnt it. So generally the acid endings, things like hydrochloric acid will form chlorides, nitric acid will form nitrates, sulfuric acid will form sulfates. So when you get the ion in the salt, for a chloride it'll be a Cl- ion, for a nitrate it'll be an NO3- ion, and for a sulfate SO4 2- ion. For other acids, generally you take the ending from the name which ends in ic, so something like citric would become citrate, and phosphoric would become phosphate, malic would become malate. So you can get used to changing the name endings on the acids to get the salt name. So let's try an equation, probably in words first, just to get the idea. So if we're looking at a reaction between calcium hydroxide and hydrochloric acid, you can see I've underlined calcium because that's the metal, and hydrochloric acid, I've noticed the ending I'm going to take is going to be a chloride. So calcium hydroxide is an alkali, so it follows the rule alkali plus acid makes salt and water. And when we're working out the name of the salt, we need to take the metal bit, which is calcium, and add the ending on from the acid, which is chloride. So that would be calcium chloride. So overall, you've got calcium hydroxide and hydrochloric acid making calcium chloride and water. However, you will have to balance this equation because you're going to need 2 lots of hydrochloric acid because your calcium salt is CaCl2. So overall, we've got calcium hydroxide plus hydrochloric acid making calcium chloride and water. You notice I've also put the state symbols in, so AQ means aqueous or dissolved, soluble in water, and L liquid for water. Let's try a carbonate this time. So if we're going to try copper carbonate and nitric acid, following the rule carbonate plus acid makes salt water and carbon dioxide. The salt will be copper nitrate, so when you're putting together the word equation, copper carbonate plus nitric acid would make copper nitrate as the salt, plus water, plus carbon dioxide. So then carrying on into the formula equation then, you start off with copper carbonate plus nitric acid. Again, I've gone straight to the ratio this time because you need a 1:2 ratio to make copper nitrate, water and carbon dioxide. If you're struggling at all with learning the formulae, then there's also another short slide that you can have a look at about how to write out chemical formulae, more complex ones in particular. You notice here I put in S and G as some state symbols for solid and gas as well. Unusual cases occasionally happen between acidic and basic gases. So, for example, ammonia gas and hydrogen chloride gas would make an ammonium salt, so you've got ammonium chloride. Occasionally comes up as an example. So you've got HCl plus NH3, it's NH4Cl. So that one sort of follows my last rule, or rule 5. The reactions there producing hydrogen or carbon dioxide will be seen to effervesce or bubble as a gas is produced, so it's worth knowing those from observational point of view. If we have a look at some more examples, then we've got calcium and sulfuric acid. This follows the rule reactive metal in acid makes salt and hydrogen. The reactive metal is calcium. In this case, it's obviously above hydrogen in the reactivity series in order to be a reactive metal. And when you put it together, you'll make your salt and hydrogen. Obviously, that would effervesce. Just watch with hydrogen, it is H2, it's diatomic. Okay, hopefully that's helped you a little bit on your word equations. The most important thing you can do now is obviously keep practicing. If you're still having any troubles, obviously go and see a member of staff. Obviously the chemistry staff are the best people to see. Hopefully that's been useful, and perhaps if you're still struggling with some formula, you have a read and listen to the one on formulas. Okay, thank you.